Aldehydes are more reactive than ketones towards nucleophiles or nucleophilic addition reactions. Why? First I will give you a detailed answer, then a statement answer. It is basically due to two reasons. Reason number one is electronic reason. Reason number two is steric reason. Okay, first I will explain electronic reason. Okay, electronic reason. See, listen. If you consider this bond, CO bond, we know CO bond is polar due to the high electronegativity of oxygen. Oxygen is highly electronegative. So what will happen? See, this electron pair will shift towards oxygen, make this oxygen negative, carbon positive, right? You remember, right? Now, see, the nucleophile will get attracted towards this carbon carrying positive charge, right? Now, higher the positive charge on carbon, more will be its tendency to attract nucleophile. Now, we have to check in which case carbon carry more positive charge, in the case of aldehyde or in the case of ketone. In case of aldehyde, what we can see the carbon carrying positive charge is connected to one methyl group. But here in ketone, you can see two methyl groups are connected with carbon carrying positive charge. Now, what is the speciality of methyl group? They are electron releasing group, right? Electron releasing group. They pump negative charge towards the carbon. Now, how many groups here? Only one group. And here two groups are pumping negative charge towards the carbon, right? So what happened to the positive charge? The positive charge decreases at a higher extent for ketone than aldehyde. Why? Because only one electron releasing group and here two electron releasing group. If the positive charge on the carbon decreases, then what will happen? Its ability to attract nucleophile will decrease. So which case nucleophile will be attracted more? In the case of aldehyde. So we can say due to electronic reason, aldehyde is more reactive than ketone towards nucleophilic addition reaction. Now we have one more reason, that is steric reason. If you check aldehyde, you can see the carbon carrying positive charge is connected to one methyl group, one bulky group, right? But in the case of ketone, you can see the carbon carrying positive charge is connected to two bulky group. So in which case nucleophile can easily approach carbon carrying positive charge. First case, or in the case of ketone, definitely for aldehyde, right? Here two bulky group will definitely block the path of nucleophile to approach carbon carrying positive charge. But here only one such bulky group is there. So approaching is comparatively easy for aldehyde, right? In the case of aldehyde, the approach of nucleophile is comparatively easy. Hope you understand. So due to steric reason also, aldehyde is more reactive than ketone towards nucleophilic addition reaction. And this is your statement answer. For steric and electrical reasons, aldehydes are more reactive than ketones in nucleophilic addition processes. In ketones, the presence of two relatively big substituents make it more difficult for a nucleophile to access the carbonyl carbon than in aldehyde with only one such groups. The presence of two alkyl groups lowers the electrophilicity of the carbonyl carbon in ketones more effectively than in aldehyde.